Namaste. This session is about elements and characteristics of maps. My name is Major Shivakiran. I was earlier in the army for a short while, and then last 25 years I have been associated with the fields of mapping, geographic information system, dealing with various domains and application areas. In the next session, in the ensuing session, I will try and share with you the elements and characteristics of maps. Today, maps doesn't generally just mean a map. A map means integration of various technologies which combine together to make a map. You have seen these components briefly in the earlier session. Now, we will try and see what exactly make the elements of a map and what are the characteristics of maps, and also try and understand how you go into the elements of map making, understand the concepts of geographic information system, the brick and mortar of map making and the application areas. So, we will start this session. So, as I said, taking a little recapitulating from the previous session, the elements of maps. When you talk of elements of maps, a map essentially comprises of, it should have a scale, it should have a direction and it should have a legend. These three are the basic components of a map. So, every map, as you would understand, when you use a map, it shows direction of where the north is. It has a scale, trying to say that x 1 centimeter on the map would measure x distance on the ground. It also has a legend for us to enable to understand the map, the various colors which are there on the map, the various symbols which are there on the map, and as I mentioned earlier, there is a list of conventional symbols. So, to understand a map properly, you also need to understand the conventional symbols. So, to effectively understand what makes a good map is a sense of direction, a sense of color, a sense of symbology, a sense of legend. These 3 or 4 elements would really define what a map is. But to a lot of people, even accuracy of a map is very, very important, and that they would treat it as a critical component or element of a map. So, today we use various technologies in order to be able to define how accurate the map database should be. So, we will understand through the next few slides as to what are the technologies involved, how maps are made, and the concept of map making which aids development and aids decision makers. So, parts of a map, if you have to see the basic elements of a map. Typically, we talk of map when you start using a map, you need to orient yourself on a map. You need to identify where you are on a map first. Like generally we give the example of a map and life. See, in map, if you know where you are and where you want to go, you can use an appropriate route and reach that place. Then you could use, maybe if the distance is longer, you could use an aircraft, you can use a rail train, you could drive. There are various methods, but once you have to understand where you are and where you need to be going, appropriate communication channels can be used. So, also in life, if you try to understand where you are today, all of you are students, where you are, what qualifications you need to acquire and what you want to be. So, as a process, you can understand and acquire those qualifications, and believe me, GIS technologies, map making are one of the essential tools today. No matter what domain you finally want to get into, whichever field you want to get into, if you are able to understand that, data can be put onto a map, nothing like it, and you can depict data, understand data, see patterns when you put information on a map. So, the components, as we said, orientation, it should have a title, it should have a scale, it should have a legend, location information anyway is there. So, if it has a location information in terms of coordinates, latitude and longitude, that you would generally call it topographical map, but not all maps may have a latitude longitude. As I mentioned in the session earlier, that when you have a location details of a map, it is called a georeferenced map. That is a position which has a latitude and longitude. Today, very popularly used Google Maps and the Indian made Bhuvan maps, you often talk of location sharing. When you are sharing location, you are sharing the actual latitude longitude of a place. So, every map does not have a latitude longitude. Only those maps which are georeferenced have the latitude longitude. So, in terms of parts of a map, one is the physical map. When you are talking of a digital map, it is essential normally to have the georeference map which have the latitude longitude, which you can use for a variety of applications. So, it has a legend. Now, to understand a map better, you have a legend. as I mentioned earlier, if you look at a topographical map, there is a list of conventional symbols given at the bottom of the map. So, when you see blue color, it means water. When you see green, it is forests. When you see red, it is roads. So, the legend along with the symbols in color displays the feature which is there on the map. So, before looking at a map, you have to at least cursorily go through the legend to understand what are the symbols on the map and what colors they are depicted and in what symbols they are depicted. So, normally when we see data on a map, it is either point, line or polygon. This particular legend which is there also shows you that the roads are marked through a line symbol, the railways are marked through a cross line symbol. So, they are in black, the railways are in black, the roads are in red. The water bodies are all shown in blue color, depending on the importance of water bodies, more thicker, lesser. So, also road lines are shown, highways are shown in thicker red color, the smaller roads are shown in lesser thick color. So, likewise, using appropriate symbology, appropriate colors, the legends are designed. Title, very important. By looking at the title, you should be able to make out which area it is covering. Now, typically this is an American map which is being shown to you. So, it shows you that it covers the area of America. So, by seeing the title, you can so easily know which area it is covering. It could be an Indian map, it could be Telangana map, it could be Hyderabad map. But again, please remember, we are moving into a digital environment, whereas what happens is the whole world is available to you at the press of a button. So, in those kind of situations, sometimes the titles of the maps become irrelevant, because you are seeing the entire world, entire globe in a small screen like your mobile phone. So, basically titles, when we are talking of the digital map converted into a certain area, a certain map or paper form. So, when you are printing, then it needs a title. So, depending on the area, depending on the application you are using it for, you might require a title of the map. Suppose there is navigation, you want to go to one place to another place, you may not need a title. But suppose you want to show the agricultural production of Telangana, then you would need a title of that map. So, depending on what information you are depicting, the title may become relevant. The north arrow, very important. For those who have been using the digital maps like Google, when you start putting in a location, it says move in the west direction or start moving in the south direction. So, direction orientation is very important. India traditionally had a very good system of identifying the directions. Typically, the sun rises in the east. So, we generally know which side the east is. So, also in the night time, by seeing the 7 stars or Saptarishis as we call them, we would be able to identify the north direction. Even today in villages, if you go, they say go in the direction of east, go in the direction of west. So, sense of direction has always been part of map making, and Indian tradition is known for this attribute of direction knowledge. So, north arrow on a map is very important. Why it is important is, you have to align the north on the map with the north on the ground, then you are able to orient the map properly. So, if you are looking at a map, the north is different on the ground and the north is different on the map, then the alignment is not there, then you are not able to understand it properly. So, in different areas, like especially defense kind of area, where operations are very critical, people are aligned in terms of the maps and direction on the ground. So, every map has to have a sense of direction, which is a north symbol which shows directions with which you are able to determine and see the features align the map. Scale, like I mentioned, one of the essential components of map. Now, scale is like in Survey of India maps, we just discussed, makes maps of the scale of 1:25,000, 50,000 and 250,000. So, now a scale of 1:25,000 means that 1 unit on the map is equal to 25 meters on the ground. So, 1 centimeter on the map is equal to 25 meters on the ground. So, also a scale of 1:250,000 means 1 centimeter on the map is equal to 250 meters on the ground. So, depending, if you want to cover a larger area in a smaller sheet, you need to have a small scale map, as we call it. If you want to cover a smaller area and show more details, we call it a large scale map. So, depending on the scale, the area coverage is there and the accuracy matters. So, in elements of a map, the scale is very important. Incorporating map elements, like I said, I mentioned to you that in topographical maps, you have the latitude, longitude. Today, you have various technologies of how a map can be given the attributes of latitude and longitude. So, When you look at typical map, again as I said, Survey of India is a premier map making agency in the entire country. So, it puts the latitude longitude on the topographical map. But suppose you do not have the topographical coordinates on a map or latitude longitude on the map, then what you do is you have a system called global positioning system. It enables you to pick up latitude longitude of any place, and if you have a map in which there are no coordinates, you can pick up some features for which you can collect information on the ground and attach that data to the features on the map. So, it is called attribute data. By doing that, what you do is you are georeferencing a map. Then as the slide says, incorporating map elements. Once you have georeferenced a map, you can add any more data to it. You can add data by collecting, let us say, information of the new road, information of new water body, information of the forest areas. You can use GPS to put it. So, georeferencing is very important for a digital environment. Conventional maps, you have to do physical surveys to again add more details. Map layout, normally when you look at a map, let us say you are looking at an India map, and you want to know where India is in the whole world as marked. So, you have an inset map. So, it is an index map as it is called. So, in the whole map there is another layout which is given, which indicates which part of the world, which part of let us say India, a particular state is. So, when you look at the larger map, the bigger map which is there on the map as it is shown here, the inset map shows you, the index map as we call it, or the map layout shows you where you are. The map layout is also important in the sense that when you look at a map, the title of the map, where is the basic map, what information you have given, the legend, the scale, the north arrow, where they should be placed. So, normally what we do in map making is we standardize this, so that everybody does not have to re-understand all this. So, conventional symbols are same, the title normally at the top, the roads are all colored in red, the water bodies are in blue, the forest areas are in green. Likewise, we have standardized most of the methods. So, when you see the map, you are able to understand and you are able to know where you should look for the scale, where you should look for the conventional symbols. This is how the standardized layout pattern is being used. So, as I mentioned earlier, a map actually depicts the surface of the earth. So, 3D surface you are bringing it onto a 2D surface. So, there are inherently going to be some errors, because the spherical surface you are trying to force it onto a flat surface. So, there are going to be some errors, and how much accuracy, this depends on the methods that we use to depict a spherical surface to a two-dimensional surface. There are systems called projections and datums, by which sometimes the shape is not compromised on, sometimes the accuracy of distance is not compromised upon. So, depending on our need, we look for the appropriate datum and projection system. So, as I mentioned here, large scale maps and small scale maps. Large scale maps, as I mentioned, large scale maps would cover a smaller area, show greater detail. Small scale maps cover a larger area and show less detail. So, suppose you want to see, let us say 10,000 square kilometer in one map, then you look at a scale of 1:250,000. But if you want to see 180 square kilometer with greater detail, you look at a 1:25,000 map. So, depending on whether you want to see what detail, so the scale varies. So, by using a multitude of scales, you will be able to understand your requirement better and the features better. Then normally what happens is, before you go on to a project, it is decided what scale of maps we will be using for the project. This depends on the detail that you want, on the accuracy that you require. So, these two are essential components. So, let us now slightly move on to when we say components of the map, from a paper map to a digital map, as it is called Geographic Information System, GIS. GIS is basically a computerized tool. What it does is, it collects data from a map, it stores, it helps you retrieve, it helps you transform, and finally, it helps you display the spatial data. So, now this is a software. It is a software which enables you to collect all this data, put this together and store it, retrieve, put it in different layers, transform it, and then display it. So, there are various components you say. First, collecting. Now, how do you collect GIS data? Like I mentioned, one is you could use satellite imagery, one is you could use global positioning system, one is you could use topographical map, digitize it, you could use LiDAR, you could use field survey. various methods of collecting field data are available. And once you collect this data, you have to store it in appropriate form. Now, a digital environment, how do you store it? Is you save it, like you have different tools, they have memories, and in those memories you save the data that you collected from a field, and all these are designed typically for a map making exercise. So, it enables you to store in certain formats, and then once you have done it, you can always get it back. See, you have collected data from the field, you have stored it, now you are retrieving it to make a map. So, when you retrieve it, what happens is you can retrieve road information, you can retrieve water information, you can retrieve forest information. So, depending on your need, you retrieve and then make it into a layer. Road is one layer, water is one layer, forest is one layer, habitation is different layer. You want to combine, you want to keep it different, whatever. So, software enables you to do that. So, basically it is being called a marriage between a computerized mapping system and database. The database is also called attribute. Now, you have a road, okay. Information like width of the road, when it was laid, what material it was made of, who is the contractor who laid, okay. So, all that information is called attribute data. So, attribute data can be linked to the map features which we mentioned earlier, point, line, polygon. So, you can link attribute data to it. It is also called non-spatial data or database. So, the marriage between computerized mapping and database management system is geographic information system. Only big difference here is a GIS has a location link. GIS essentially means latitude, longitude, a link on the ground. It is not some data which is floating. So, it is linked to a ground location, that is why it becomes geographical information system. Just an example to show you high resolution satellite imagery. You are able to see now this kind of imagery. If you see here, you are able to see each tree which is being planted there, which is being looked after, and as I mentioned earlier, we are beginning to use all these terms together. You use maps, you use geographic information system, you say geomatics, you talk of geoinformation technologies, you talk of geospatial technologies, all are bringing technologies together, and finally, in a conventional term they make a map, and when you convert that into digital environment, it is called geographic information system. So, maps and GIS, these are more commonly used terms, but they are all changing depending on the expertise that is coming in and how people are using it. But just wanted to again mention here about this high resolution satellite imagery. If you see here, this is almost 1 centimeter satellite imagery resolution. You can even see each tree. Now, with this kind of applications, you are able to monitor plantation activity. Suppose an area has been taken up for plantation. How it is changed next year? Has it grown? Has the trees still been there? So, that kind of monitoring is possible. Now, it gives me great pleasure to also tell you that now this particular image is being shown from an American satellite imagery, but India also today has very good satellite imagery. We are doing much better than 1 meter satellite 1 meter resolution, which enables you to do similar exercises. But people like you who come from various domains or pursuing geography as a career objective have to understand that satellite imagery is today available, and this is available at an indigenous level. When you say make in India and other kind of projects, Indian data is amongst the best in the world today. Only thing is you have to start using it. You have to understand how to use it, and you have to use it for various applications. The National Remote Sensing Center located at Hyderabad has a very nice team which enables various government agencies and private sector to use satellite imagery. Just one more point I want to mention here is the repeating of satellite imagery. Every 21 days you get a fresh picture of an area. Just imagine you can analyze every area every 21 days. So, if you have taken a picture of today, next after about 3 weeks you can get the image of the same area. You can see the changes, and sometimes for emergency responses, suppose you have floods or suppose you have an earthquake, at that time you can get real time imagery also, what is happening on the ground. That kind of technology is available with National Remote Sensing Center, and Indian satellite imagery is available through BHUVAN tools. So, if you explore BHUVAN is India's equivalent of Google. So, sometimes instead of trying out Google, my request is you should also look at BHUVAN, and it will enable you to try out various applications, and believe me, this data is Indian data. So, whatever data is being put there or used for various applications is going to remain with us. Thematic maps, further on, as I mentioned here, suppose you want to go into the area of agriculture, soils become very important. Now, as a geography person who is doing a program in undergraduate in GIS or a PG in GIS, geography, you understand geography and GIS is a tool to be used for other areas, like agriculture scientist comes in with some data. So, you have to be able to put the data onto the map and show him the data with a spatial perspective. That would enable him to take decisions. So, also a slope map, so also geomorphological map, water maps, okay, transport network. You just think of it, any domain using their databases, if we can put it onto a map, like I mentioned just before, it is a marriage between computerized maps and databases. Use the databases, put onto a map using your geographical skill, then you are entirely changing the understanding and perspective, with which they will get a better understanding of how to use their domain knowledge. So, your role is limited to putting the database onto a map or a computerized GIS environment. Do not get into their roles. See, like agriculture scientists in agriculture, that is a specific area. Let us say disaster management exercise, that is their area. Health expert, likewise water resources. Your domain is geography. So, if you are able to use maps and geographic information system to be able to create map databases out of their databases, it will be very useful and it can help decision making. So, as being mentioned, and some of you would already be aware, when you look at a map, there is a lot of information on a map, starting from water bodies, forestry, roads, etc., etc. Now, you see in this thing, in this slide, there are layers of data. You are using data from land surveying, you are using data from photogrammetry, you are using data from high resolution satellite imagery, from various sources and putting them together. And depending on your requirement, you can add a layer or remove a layer. That is the strength of GIS and computerized mapping. Always you do not have to have all the data together. Suppose you want to understand roads and water bodies, you can combine these two layers and understand where are the areas where I can lay new roads. That is the essential difference between a conventional mapping and a computerized mapping. And what else in terms of GIS that they have? See, it is a map database, like I told you. It has a software, it has data, it has hardware, it has procedures. More importantly, right now is the people. This field of geographic information system and mapping needs trained people like you, people who come from geography domain, people who come from GIS background, to be able to put this data onto a digital platform and make them understand. Just presenting some cases here, typical how you can do land use mapping, a small urban scenario, only about 3,500 houses plus about 20,000 population. If you now look at this area, straight away when you look at the map, right, you can see different colors. One is you are able to see yellow color, the green color and the blue color. Typically this has been done, this has no legend. So, try and tell you that a correct map would have a legend to understand the blue areas would mean certain activity. So, in this area it is a urban habitation. So, the blue area is a commercial area, the green area is the green area, which is the greenery areas, and the yellow ones are the residential areas. So, three areas land use mapping has been done, all right. Now, if you understand this, if you see, the green areas are very limited, only limited to northern parts. So, in an area like this, the municipal commissioner can take a decision and say, I am going to develop parks in the southern area. Now, if you see, some blue areas are also there in the internal areas where the residential areas are there. So, you cannot have commercial areas in midst of residential areas. So, they need to be shifted. So, as part of urban planning, when you put this on a map, you are able to understand where what should be. In residential areas, you should have residential activity. In greener areas, you should develop greenery. Commercial areas, you should have commercial areas. So, land use mapping is done, master plans are being developed, zone regulations are there. So, whichever area is residential should be restricted to residential. But how do you monitor? You monitor using mapping. You create a map database like this, which enables you to see whether the zoning regulations are being followed or not. So, this is for the area of Hyderabad. A small project was done covering entire, I have shown you a small area, but entire city was covered, and then it enabled the Greater Hyderabad Municipal Corporation to take lot of decisions which otherwise could not be taken. the rationale for research was that there seemed to be scope for improvement of delivery of services to the citizens, be it water supply, be it sanitation, be it your road services. So, for that GIS was used. So, how did we go about doing this? First, we created a map database of an area, then added lot of information to it, layers of information, and then created a GIS database, and then queried the GIS database to create results. We will next in the few slides show you how this can be done. So, this is a small area, as I mentioned, an area called Greenlands in Begumpet area, which was taken up as a case study. So, repeating this map earlier on. So, if you see the map on the right side, it shows you the areas in where commercial activity is there in blue, the areas which are there in yellow are the residential areas, the areas which are in green are the greenery areas. So, how did we go about this, which is essential part of map making or a GIS is first identifying the objective. Why are you doing this? So, in this case we did this to improve the service quality in that area. Then identifying steady area, which area are you going to do this, because you need map database of that area, you need other database of that area, that is very, very important. And then you need to collect, also prepare field preparation, and then integrate this data together to be able to generate patterns. So, in this case what we did was we used Survey of India maps, we used all possible maps. See, maps are there today. The point is sometimes people say maps are not there, but they are there. You have to make an effort to find those maps, put them all together. They could be on different scales. So, putting them together on different scale maps also is a skill which people like you with a geographical background will understand much better than others. So, you have to develop from geography to geographic information system, use all these different kinds of maps. So, you have to prepare pre-field preparation, collect the maps, go to the data, go to the field to collect appropriate data. And how do you collect data? Like I mentioned, you have an instrument called global positioning system that gives you the latitude longitude of a place or any feature that you want to. So, that can be overlaid on the GIS. So, what essentially was done in this particular project was data from GHMC, Metro Water Board, police, electricity department, all was collected, and this was put on one map so that all can use this data at one point of time. Different data can be brought together, different department could use this data. Base maps were made first. See, this is the point of scanning of a map. All this you will understand when you convert a paper map into digital form. There are issues of scanning, more accuracy, better resolution. You want to see the map better, you have to scan it at a higher DPI, we call it resolution, dots per inch. Depending on the hardware that you have, you could do a lower level of scanning also. So, we collected various data like property information from GHMC, census data, and using all this we started generating maps. So, I am just showing you some examples of thematic maps. So, if you see here land use maps, now this is typical land use map. So, residential areas, parks and commercial areas. Straight away when this is shown, you have an understanding of how the area is. Predominantly this is a residential area, and you see the blue highlighted properties in blue, they are closer to the road. So, some are internal. So, these need to be moved out, and if you are taking up greening activity, you know which are the areas where you want to take up greening. This is a very good example of how a decision support system can be developed. So, we also have a floor map where permissions have been taken, but they have deviated from that. So, if you see this particular area again, the areas which have broken the rules are in again blue. So, those are the areas where the municipal commission needs to be give attention. But one point you need to understand is it is the same map which is being used for these two purposes. This shows the water cess. So, I have shown you one example of land use, one example of unauthorized construction, one example of water cess. So, water dues to be collected. Where are the water dues to be collected from? This map highlights that. So, same database using for different purposes. So, I told you about little bit about attribute data. So, whichever data is there on the map, it has a link. It has the serial number, it has the nearest house number, manual ID, this can always be linked. So, just run you through one again example of raster image. Over that you are digitizing, you have digitized using the GIS software to create plots. Then you are putting the electric poles on this, various layers of information if you see this now. On the image you have digitized the plots, you have put up the poles, then you have put the parks, you have put up the street lights. See, these are various information, and now we have combined street light with roads. Imagine this is for security purpose. If you combine street lights with roads, you would know where are the gaps. So it works for the police to understand where the street light should be put, for the municipal corporation next level where they can put the street lights, so that security of the area is established. So this is how mapping will help. Now using all this, as you see, the map is the center, the attribute data is attached to it. Because now it is georeference, you can draw circles around it, you can measure distances. This is a 100-meter buffer. So it has tremendous applications. Once you move on from a map to a GIS, it has various application areas, and it is your imagination will enable to do that. Now using small example, I have shown you how satellite imagery can be converted into a vector map. With this kind of tools, with moving on from a map to a geographic information system, you can enable creation of latest databases. Now what essentially this does is, you are moving on from a conventional map database to a digital environment. This is technology in use, and indigenous technology is available in our country, and as I mentioned, across domains this can be used. Now no matter which profession you want to get into from a basic qualification in geography, you can enable people to use map databases, and this is growing. There are various opportunities for students in this area. So like I said, you can go in from agriculture to transportation to law and order, from water management. So a bigger word is called sustainable development goals. Now the whole world is today talking of sustainable development goals. For this you need an integrated approach, and geography, GIS and students like you are going to be very crucial in bringing all this data together, so that leaders can take decisions for a better world. Thank you so much. Jai Hind.